So today what we're going to see is a situation where the empirical rule doesn't help us very much. And in all honesty, if we were in the classroom and had the graphing calculators, this lesson could be done in 15 minutes. But I'm going to show you the long way of how to do this because you don't have the TI-84s and because it's useful to see the lengthy process of how to actually calculate these values using tables. So we're going to start off with this first example, and I don't know that we'll get to the rest of these examples today, but we're going to assume that a population of students is normally distributed, and that's pretty important because that says we can use our normal distribution curve. The students have a mean test score of 83. I'm just going to make a note of that. And a standard deviation of 3. Where do the following students fall on the bell curve? So what I'm going to do is, I could draw the whole bell curve, but here's the bottom of the bell curve. And if you want to, you could just picture, the bell above here. And in the middle, this would be the mean, which in this case is 83. And then we would have one standard deviation above, which would be 83 plus 3, and two standard deviations above, which is 89, and three standard deviations above, which is 92. Okay, we could also go the other direction. You get the idea. 80, 77, 74. All right, so these are all standard deviations beneath the mean. So where do these people fit? Because their scores aren't all perfect in that they're not going to land right on these markers. Charles is in good shape because he's right here at 89%, which is right on the second standard deviation mark. So if I'm trying to figure out where Charles falls, that's very easy. He's right at 2 standard deviations. Jill, though, is a little bit of a problem because I see a range here between 83 and 86, but I don't see an 84.5 anywhere here. And remember, our empirical rule is going to tell us that 68% of our data falls in this range. And I could say then that if I divide that by 2, 34% of my data is here, but I'm not sure exactly where Jill falls here. So Jill is in this range somewhere. And she would be exactly halfway between those. So there are some tables that would show us that. Allie is really hard to figure out because Allie is not exactly halfway between -1 standard deviation and the mean. She's a third of the way there. So Allie is like here. And so now we run into some problems when we're asked questions like this. What percent of the population scored between Charles' score and Jill's score? This is not going to be easy to do. The empirical rule is not going to help me very much. So before I can do anything about those numbers, I need to figure out exactly where Allie and Jill's scores fall. I need to know where on this bell curve they land. I can do that by calculating what we call the z-score. Of each person. And what a z-score is it just tells us the exact amount of standard deviations from the mean that it lands on. So the formula for a z-score, if I want to know the z-score, I can just take that number, subtract the mean from that number, and divide it by the standard deviation. And so this is a little formula we're going to use today and maybe in the future. So as an example, if I did this for Charles, we're going to get a number that we would have predicted. So to get Charles's z-score, I'm going to take his number, which is 89. I'm going to subtract the mean, which is 83. And then I'm going to divide by the standard deviation, which is 3. And since 89 minus 83 is 6, 2 is Charles's z-score, which is exactly what we saw, right? Because he fell exactly on the second standard deviation. So that's what these numbers tell us. So let's do this for Jill and for Allie as well. For Jill, that's going to be 84.5 minus 83 divided by 3. And so that ends up being 1.5 over 3. And 1.5 divided by 3 is 0.5. So that tells us that where Jill lands right here is, and I could mark it, right at the mean plus 0.5 standard deviations. And so we would say Jill's z-score is 0.5. And we can do the same thing now for Allie. So I'm going to take Allie's score, which is 81. I'm going to subtract the mean, which is 83. And I'm going to divide by 3, which is negative 2/3, or negative 0.667. And so Allie's score, z-score, is negative 0.66, and it's 66 repeating, but eventually we do have to round wherever we've decided to round to. So this would be at the mean minus 0.66 repeating standard deviations. And so the reason this is going to be useful now is we know exactly where they fall on the bell curve. It's not an approximation anymore. Now the empirical rule doesn't help us, but I'm going to show you some tables here that are going to help us. So this table, which looks a little overwhelming at first, is showing us, and this is only half of our table, but it's showing us the area under the standard normal curve to the left of your z-score. So whatever z-score is given, in 2, 0.5, negative 0.6667, this is showing us how much data there is to the left of that mark. And you'll notice all of these z-scores here are negative. So this half the table is just the half the table that we could use if we had negative z-scores. And so what you can see is an example here of, if you knew the z-score, what these numbers show us is how much of the data is there from that z-score under the curve to the left. So if we went way out to the left, negative 3.4 standard deviations, crazy far away, there would still be 0.0003 of your data under the curve to the left of that mark. But once we get closer and closer to the mean, and when we get to, let's say, negative 0.14, now there is 0.4443 of the data under the curve and to the left. And obviously once we get to 0.0, we can see that's 0.5, and because that's right at the mean, so obviously half the data would be to the left of that. So right now this table can only be used for Allie, and so we're going to find Allie's z-score here on this table, and that's going to tell us how much data there is to the left of Allie's score. So it's negative 0.6667, all right? And this table doesn't get into the thousands or the 10,000s place, it's just to the hundredths place. But let's find negative 0.6 here on the left side. So negative 0.6 is there, and I'm going to go across until I see 0.607, because I want to add and I'm just going to rewrite this the way that it needs to be written for the table, negative 0.67 with rounding. So I've got my negative 0.6 here, and this will be negative 0.60. This will be negative 0.61. This would be negative 0.62, 0.63, 4, 5, 6, 7. So right there, negative 0.67, that's telling me the amount of data that is to the left of Allie's score. So if we pretend for a moment that this is Allie here on this diagram, that's telling me that if I fill all this in, that is approximately 25.14% of the data. So now I know a really good approximation of how much data there is in that range. Now I'll show you the positive side of this z-table. So you can see that this is still showing us the data to the left, but now we have our positive z-scores. So all of these numbers are really large because it's including the half that we just considered in the negative values, plus however far we are along on the x-axis. So if we find Charles is at exactly 2. So that's right here, 2.00. So Charles has 0.9772 of all the data to the left of Charles, meaning if Charles is right here, and that's Charles's z-score, he is higher on this x-axis than about 97.72% of the people. And again, we're talking about their scores on some sort of test, right? So that would mean that Charles did better than about 98% of the people who took the test. Now let's find Jill's score. She's at exactly 0.5, so that's right there. And so Jill is better than approximately 69.15% of the people who took this test. So if we go back to the question that was asked, it says, what percent of the population scored between Charles's score and Jill's score? And so in order to do this, I'm going to visualize this by drawing a little bell curve here. And so what I'm going to do is I'm going to drop Charles, Jill, and Allie onto this bell curve. Charles goes out here, right? His z-score was 2. Jill goes about here. Her z-score was 0.5. And Allie goes here, negative 0.67, standard deviations. So I'm going to visualize these percentages now, and you'll see the way that we're going to calculate this final number. So let's take Allie's number first, and we'll use green for Allie. So if I take the amount of data that we were told exists in that range, all right, that's all that data, that was approximately 25.14% of the data in that range. Now let's take a look at Jill. I'll use yellow for Jill. Jill is here at 0.5. Now remember, that number that we see, that 69.15%, that's including not just this data, but also all of the data that was beneath Allie's score. So that yellow number there, which includes that 25.14%, so let me get rid of that now. I'll just cross that off. That total number is 69.15%. That's all of that yellow data. And then we've got Charles's score. Charles's score we can do in blue, I guess. We're still using blue here. So there's Charles, and if I highlight in the blue data, that's all of this plus all of this. And that works out to be 97.72% of the data. But what we've been asked for is what percent of the population scored in this range. So I don't want that whole 97.72%. I only want the 97.72% that is not also included in Jill or Allie's data. So what can I do to find that number? Well, if that 97.72% includes all of this, then I want to take the amount of that data that is not this data. And so to actually make that calculation, what I'm going to do is take the 97.72% and I'm just going to subtract the 69.15% of the data where Jill's amount of data picks up, because I want to know just this portion of the data. How much of Charles's data does not also include Jill's data? And so when I do that subtraction, I end up with 28.57%. So when I answer that question that we were asked to answer after the first part of the notes, we would say that it is about 28.57% of the data that is between Jill and Charles's scores. And I think in a future lesson we'll continue more with these tables, but I'm going to send you these PDFs so that you have these tables available to you, and we'll do a little bit more work with them in the future.